So this is the quiz that you guys just took, dealing with our exponential models. And so our first question, we have the painted turtle population in a protected wetland grows at a continuous rate, right? If it's growing, then it's getting larger. So we're going to have a positive exponent. And that word continuous tells us we're going to be dealing with the irrational number what? E. Yeah. So think of PERT. At 6% per year. So 6% represents our R, but we need to convert this to a decimal. So this is just 0.06. And then we have, it is estimated that the population in the year 2020 was 5,000. 5,000 represents our initial amount, which isn't our E, it's either the lowercase letter A or P. Yeah. Sometimes you'll see it as like N sub 0. These are all just synonyms of one another. And this is 5,000. And so this first part of the question is asking, find a function P of T that models the population T years after 2020, which is just saying T, when T is equal to 0, we're starting at our y-intercept. We're at the initial amount. So we're going to keep T as T because we're just finding our general equation. And our general equation for any exponential growth function is our PERT, P-E to the RT, or again, A-E to the RT, or N-E to the RT. These are all equal or synonyms of one another. And if you know your P is 5,000, then you just get 5,000. E, you know your R is 0.06, so you get 0.06 T. And that's it. This was first part of the question. Now, what are the unit measures? P of T is representing what? Your total turtle population. So we were looking at the turtle population in 15,000 years, which is crazy. Okay, let's say 100 years. It would be blank number of turtles. All right, so the part B of this is saying after how many years will the painted turtle population reach 10,000? So what we're doing now is we want T to be, well, T is what we're finding. So after how many years we want to find T. But our P of T is going to be 10,000. And now we just solve. So inverse operations tells us to divide both sides by 5,000. Exactly, we get 2 is equal to e to the 0.06t. And then inverse operations tells us to take the natural log of both sides and then use properties of logs on that right-hand side to bring that exponent out in front. Our ln of e is just 1. So we're really just looking at ln of 2 is equal to 0.06t, which we could turn into a fraction. I'll show you guys both ways. And then the last step is to divide both sides by 0.06. So if you kept it in decimal form, you could have had it as ln of t or ln of 2 over 0.06 years. Make sure you put in those units. If you put it in fractional form, 0.06, put that up here, is the same as 600ths, which is the same as 5 over 50. No, sorry, 3 over 50. And so utilizing your keep, change, flip, that's the same as 50 ln of 2 all over 3 years. So either would suffice for your final result. You would get full credit. Okay, so let's go ahead and turn the page and look at our question 2, which is dealing with half-lives. We have the half-life of radium 226 is 1600 years. So let's write off to the side our H, aka our half-life, is 1600 years. Suppose we have 22 grams of our sample. So that's going to be our initial amount. Our m sub 0 is our 22 grams. We want to find a function, and they give us the function, so we're going to utilize that. That models the mass remaining after t years. And they also give us that our relative decay rate is just ln of 2 over h. We're decaying. Half-life is decaying, so that's why we have that negative in our exponent. So our r, if we plug in our 1600 for h, we just get ln of 2 divided by 1600. And now just let's plug everything into our formula. We're keeping t as our variable t. And when we do, we get m of t is equal to, bless you, 22 times e to the negative ln of 2 over 1600 times t. And that's it. Now this was our part A. Our part B is now saying how much of the sample will remain after 4,000 years. And so now we know what our t value is. Our t is 4,000. We just want to plug in 4,000 into our formula that we just solved or created, and then find our final result. So wherever you see a t, you're going to go ahead and plug in 4,000. And so we can't do a lot of simplification here, but we can still simplify a little bit. Can simplify that 4,000 divided by 1,600. Two zeros cancel out in the numerator and denominator. And then half of 40 is 20, half of 16 is 8. Half of 20 is 10, half of 8 is 4, and then half of 10 is 5, half of 4 is 2. So we can rewrite this as 22e to the negative. We can put that 5 in front, so negative 5 ln of 2 all over 2. And then what are our units? Grams, right? We want to figure out how many grams of, what was it, radium? Yeah, are left after 4,000 years. And that's it. Yes. Say that again? That's fine. Yeah. Yeah. Usually you want to simplify it to fully simplified form, but yeah, it's not the end of the world. Right. So yeah, that completes our quiz 13.